All right, Matthew, here we go. We've got just a little bit of a review of some of the stuff that we've learned about quadratics, just to kind of bring it all together here. So this is our quadratic review note. Remember, quadratics are when we have an x squared in the equation here, which we do, and these are going to make those U shapes. Okay, so they're called parabolas. First thing we're going to do with this equation is to make a table. So when we make a table, we're going to just plug in -1 to both of the x's and then solve to find out what we get for y. So like when I plug in -1 here, remember you square it first, and then order of operations says you multiply by the -1 out here. So if I square -1, I get 1, and then it's negative, because the negative out here changes the sign. So square it first and then make it negative. So that's -1. -6 times -1 is +6, plus 6, and then -8. Okay, so I've got -1 plus 6 minus 8. That should come out to -3. There's my y value. I plug in 0. That's pretty easy. 0, 0, -8. I get -8 here. I plug in 1. 1 squared is 1, and then it's negative. So -1. And then -6 times 1 is -6. And then -8. So I got -1, -6, -8. That comes out to -15. So here we can see that our numbers are getting smaller and smaller and smaller. And I believe they will continue to do so. So we need to find out where our intercepts are going to be. So we'll just keep on plugging in these numbers. Let's see. -2 squared is 4. Make it negative. That's -4. And then -6 times 2 is -12. And then -8. So that's -24. 3, when I plug it in, I get 9. Then I make it negative. So that's -9. 3 times -6 is -18. And then -8. So this is -27, minus 8 is -35. Let's plug in 4. 4 squared is 16. I make it negative. It's -16. -6 times +4. Why was I saying negative? Anyways, -6 times 4 is -24. And then -8. So 16 and 24 makes 40. So that's -48. All right, so we don't see where this one's turning around. So we kind of see a problem with just graphing these is sometimes if you're graphing them, it's hard to find out where those intercepts are in the first place. And we can't see the x-intercepts here, because remember that's when y is 0. So the x-intercepts aren't in this area. So sometimes if you're doing these, graphing, not the best method for doing it. So let's go ahead and factor and find the x-intercepts instead. Okay, so since I have a negative out front, I want to factor out that negative. So I'm going to put a negative out front, and then this is going to become positive x squared, positive 6x, and positive 8. All right, so when I factor this, what multiplies to give me 8, but adds to give me 6? That would be 4 and 2. 4 times 2 is 8. 4 plus 2 is 6. So this one factors into x plus 4 and x plus 2. Okay, so using the principle of zero products, I can now find out where the intercepts were. So remember, that's when you take your two factors and you set them equal to 0. So we do x plus 4 equals 0. So that means x is -4. We do x plus 2 equals 0. And that means x is -2. That's why I didn't see the intercepts, because they weren't in these numbers. The intercepts were over here somewhere. So just plugging in numbers usually isn't so helpful for when you're graphing it. So if I decided to graph this now that I know that, I guess I should use a ruler, maybe. Now I know that my intercepts are at -4 and -2. So my intercepts are here and here. Okay, that means that my axis of symmetry is right in between them. And my vertex should be somewhere on that axis of symmetry. That axis of symmetry is at -3, an x value of -3. So let's plug -3 into here. So I'm now moving on to this section here. So I'm going to plug in -3, and I'm going to get, let's see, -3 squared is 9, and then it becomes negative, so that's -9. -6 times -3 is +18, minus 8. And if I add these two together, it looks like I get 1. So my vertex, I plugged in -3, and I got 1. So my vertex is at -3, 1. So here's my vertex right here. Okay, remember we used the axis of symmetry. Find the axis of symmetry. It was x equals -3. The axis of symmetry is always directly in between our two intercepts. We found our intercepts by factoring it. Okay, we are missing our y-intercept, but we actually have it over here. Our y-intercept is 0, -8. 1, 2, 3, 4, 5, 6, 7, 8. Way down here, didn't make my graph big enough. And then this one would be at -1, -1, 2, 3. And then we would, since we have the axis of symmetry there, we would have another point on the other side. And those are a parabola going down to there. That was really bad. But you get the point. All right, so don't just start randomly with a table. Doesn't help because you don't know if you're actually going to find your intercepts, and that's what you're really looking for. So factoring to find your intercepts is usually a pretty good idea. All right, let's move on. Oh, other thing. Since there was a -x squared, that's why this faces down. So if there's a negative out in front, that's going to be a parabola that faces down. If this were positive out front, it would have faced up instead. All right, now let's talk about solving them. So when we're solving our quadratics, we're finding our x-intercepts. Okay, and there were 4 different ways that we found how to solve it. The principle of zero products, that's where you factored it and set them equal to 0, kind of like what we did up here. The square root method, that's when you're missing the middle term. So like if you had x squared, I don't know, -5 equals 0. On this one, we're missing that x term in the middle. So what we would do, we would just add 5 to both sides and then take the square root of both sides to solve it. Completing the square method, that's where we found the number that made it a perfect square. We'll do one of those in a little bit. And then the quadratic formula. That's x equals -b plus or minus square root. The song, there was the song. You remember the song? Here, I'll sing it for you. X equals -b plus or minus square root b squared minus 4ac all over 2a. So we had that. All right, now there's also a bunch of different forms. Oh gosh, sorry. For quadratics. We can have factored form where it's factored for us. And when we had it in factored form, we found out that the principle of zero products was the best way to do it. So this is factored form, it's already factored for us. And that's where we just set these equal to 0. So it's pretty easy to solve that one. Vertex form, we're going to get to more of that in another unit. But vertex form is when you have a perfect square in here. So this would be like x minus 5 squared plus 6. What we would do is we would subtract 6 from both sides and then take the square root from both sides. That's the square root method. And then we've got standard form. So when we have it in standard form, like that previous problem, this was in standard form. It really depends on the problem which method you want to use to solve it. You should always try to factor first. If factoring doesn't work, you look and say, okay, is it missing this middle term, this bx term? If it is, it looks something like this, and we want to use the square root method. Finally, if those two methods don't work, then you either complete the square or do the quadratic formula. All right, let's look at a couple examples. Okay, example number 1 here. It says to solve, which means that we're looking for the x-intercepts. So this problem here, this one, it does factor. What multiplies to give you 12, adds to give you -8. That would be -2, -6. So the fastest method would be the zero product method because this one does factor. Now this one could also be done with completing the square. If we subtract 12 from both sides, and then remember we can take half of the -8 and square it, and then that's the number that you add to both sides to complete the square. So that would work. And then of course the quadratic formula always works. So you could do the x equals -b plus or minus square root b squared minus 4ac all over 2a, where a is 1, b is -8, c is 12. But for number 1, I would definitely factor it because we said what multiplies to give us 12, but adds to give us -8. And that we said was -6 and -2. So this factors into x minus 6 times x minus 2. And now we can see that we just set these equal to 0 using the zero products method. X minus 6 equals 0. X minus 2 equals 0. So add 6 to both sides. One of our x-intercepts is at 6. The other x-intercept when we add 2 to both sides is 2. That's the fastest method. If it factors, that's your fastest method. The quadratic formula would take you a little bit longer. All right, next one. This one's in standard form. So standard form like this one. And it's missing all the lights. Knuckle sandwich. All right, so it's missing that middle bx term. There's no bx term. So for this one, I would probably use the square root method. Now the quadratic formula would work on this one. A would be 4, B would be 0, because there is no bx term in the middle. And C would be -5. Quadratic formula always works, so we could do that too. But I think personally that the square root method is the fastest method for solving this one. Here's how it would work. We'd do 4x squared minus 5 equals 0. We'd add 5 to both sides, get 4x squared equals 5. We divide by 4. We get x squared equals 5 over 4. And then we take the square root from both sides. So when we take the square root, remember you do plus or minus, and this would be the square root of 5 over the square root of 4. And the square root of 4 does reduce. This would be plus or minus square root of 5 over 2, and that would be our final answer. So that is much faster than doing the quadratic formula. So if you're missing the bx term in standard form, you should probably use the square root method. All right, next one. This one, if we multiply 3 times -3, we get -9. There is nothing that multiplies to give us -9 and then adds to give us -1. It just doesn't exist. So we can't factor it. We can't use principle of zero products. It has an x term in the middle. So that means we can't use the square root method. Now we could complete the square, but there's a problem. This number out here is going to give us a lot of fractions. And then this number in here is a 1. Usually we want this to be an even number to do completing the square. So completing the square would work. It would just be really ugly all the way through. So probably the best method for this one is the quadratic formula. Since it doesn't factor, you can't do the square root method, and completing the square would be a pain in the butt. So for number 3, move this down. For number 3, we would just do, okay, A is 3, B is -1, and C is -3. And then we'd use the quadratic formula. X equals -b, so -1, plus or minus the square root of b squared, so -1 squared, minus 4 times A is 3, times C, which is -3, all over 2 times A, and A was 3. Okay, I clean it up in 4 steps. First thing that I do is clean up this negative 1. So that would be 1 plus or minus. Next step, -1 times -1, that's always going to be positive when you square a negative. -4 times 3 is -12. -12 times -3 is positive 36 over 6. And so I combine here, and I get 1 plus or minus root 37 over 6, and we're done. So quadratic formula was definitely the best one for that one because it didn't factor and it had a bx term in the middle. All right, zero products. This one is in factored form. So you definitely just want to use the zero products. Since it's already factored, you can do x minus 7 equals 0 and x plus 5 equals 0. And then x would be 7 and x would be -5 because I add 7 to both sides and I subtract 5 from both sides. Now, could we do the quadratic formula? Yes. You would have to do the area model first and multiply this out to put it into standard form like this. So you could use the quadratic formula, but not in its current form. Zero products would be faster. All right, last one. Now this one, there is nothing that multiplies to give us -1 and adds to give us 6. So it doesn't factor. We can't use the zero products property. It has a bx term, so I can't use the square root method. So I'm down to completing the square or the quadratic formula. Now on this one, I would probably complete the square for this reason. Number 1, the number in front of x squared, the a value is 1, which is what we want. And the b value is even, which is what we want. So completing the square would probably be faster on this one. We could do the quadratic formula. A would be 1, b would be 6, c would be -1. But I think completing the square is more efficient on this one. Efficient meaning that it's probably going to get our answer faster and we're going to have to do less work. So if I was completing the square, I do x squared plus 6x. I'm going to leave a blank here. I add the 1 to both sides. So 1, and then I leave a blank. Okay, I'm going to fill in this blank. The way I find the number that completes the square is take this b term, cut it in half and square it. 6 cut in half, square. So that's 3 squared, which is 9. So I add 9 to both sides. This is a perfect square. We just squared 3, so this is x plus 3 squared. And then 1 plus 9 is 10. And now we can take the square root from both sides. The square root of this side would just be x plus 3, because square roots cancel squares. Since we took the square root, we have to do plus or minus, and then root 10. Last step, subtract 3 from both sides. And there we go. All right, so know your methods because some of them are more efficient depending on the problem. Practice will kind of help you decide which method is the most efficient for the particular problem that you're doing. So keep practicing those quadratics. See you later. Bye-bye.